A real number can be positive, negative, or zero. We can represent all real numbers on a number line. 0 is neither positive nor negative. The numbers to the right of 0 are positive, and the numbers to the left of 0 are negative. As we know, all positive and negative whole numbers, including 0, are called integers. So 0, 1, 2, 3, minus 1, minus 2, minus 3, etc. are integers. Between any two integers, there are decimal fractions. For example, 0.5 can be plotted between 0 and 1. Minus 2.8 can be plotted between minus 2 and minus 3. Each real number can be expressed as a decimal. For example, 2 equals 2.0, 2 by 5 equals 0.4, 1 by 3 equals 0.33333. Square root of 3 equals 1.732050. Real numbers can be classified into two main categories: rational and irrational numbers. Numbers of the form p by q are called rational, where p and q are integers and q does not equal 0. For example, 3 by 1 equals 3, which is an integer. Then 5 by 4 equals 1.25, which has 2 digits after the decimal point. That means the number of digits after the decimal point is limited. So it's a finite decimal fraction. Then 2 by 11 equals 0.181818. In this fraction, after the decimal point, the digits 1 and 8 appear together repeatedly without end. So it's an infinite repeated decimal fraction. Thus, it appears that if the rational number is expressed as a decimal, it will either be finite, or if it is infinite, it will be repeated. If a number cannot be expressed in the form p by q, where p and q are integers and q does not equal 0, then it's called an irrational number. For example, square root of 2, cube root of 11, square root of 5 by 2. If we express these numbers as decimals, we see there is an infinite number of digits after the decimal point, and no digits appear repeatedly. So these fractions cannot be expressed as p by q form. These fractions are called infinite non-repeating decimal fractions. Thus, when an irrational number is expressed as a decimal, it's neither finite nor infinite repeating, and it's an infinite non-repeating decimal fraction.